video, we are going to talk about how to factor by completing the square. Completing the square is very useful for several different things in math. The first reason it's important is when we go to graph a quadratic function. Remember that a quadratic function is a function where your highest exponent is 2. And it makes the shape of a U. We call that a parabola. And so when we're looking for the vertex, which is the turning point in a quadratic function, it is very useful to complete the square of a quadratic function. That will help us find our vertex. But in this video, we're just going to focus on actually the factoring piece by completing the square. I have a link here for you to click on for the WikiHow, and that will take you through the steps, step by step, and you can go through an example there. I'm also going to go through these 5 examples that are in your packet. So you can work through these examples and pause the video and press play to help you as you go through these examples. The very first example is 3x squared plus 24x plus 5. And we mark off the first 2 terms. Do not take out a variable, only you really want to focus on just getting rid of the first term. So we're going to factor out a 3 here. That leaves me with x squared plus 24 divided by 3 is 8x, and then we have our plus 5 on the outside. Now when you go to factor by completing the square, you always look at this middle term here. So I have 8. You take half of that number, which is 4, and you square it, which gives you 16. So we have 3x squared plus 8x, and then we add 16 inside these parentheses. Since we added 16, you're also multiplying by 3, then we need to subtract 3 times 16. When you factor this, you want to look at, well, what are the 2 factors of 16 that add up to 8? It's always going to end up being the square root of this last number, or this number right here that you got. So it's going to be x plus 4 quantity squared plus, and then simplify this. 5 minus 3 times 16 is actually going to be a negative 43. So 4 times 4 is 16. 4 plus 4 is 8x. And so you could always check yourself by expanding this x plus 4 quantity squared out and distributing your 3 and working backwards to get your original equation, 3x squared plus 24x plus 5. Look at this next example. We're going to break down 2x squared and 6x. So we take out a 2. That leaves you x squared minus 3x plus 1. Take your middle term and take half of that and square it. So half of 3 squared is 9/4. So we have 2 quantity x squared minus 3x plus 9/4 plus 1. And if we add 9/4, we need to subtract 2 times 9/4. Don't ever forget this number on the outside. Then you can go through and you can factor this. X minus the square root of 9/4 is 3/2. Quantity squared. And 1 minus 2 times 9/4. You can use your calculator to simplify this. 2 times 9 is 18. 18 over 4. It would be smart to change that 1 to a 4 over 4. 4 minus 18 is negative 14. Negative 14 over 4 would reduce to negative 7/2. In this problem, x squared minus 18x, I do not have a number that I need to get away from my x squared. So I'm going to look at my middle term, I'm going to half it, and then I'm going to square that number. So I have x squared minus 18x plus 81 plus 100. And if I add 81 here, I need to subtract 81 here. So factoring this, that's x minus 9 quantity squared, and 100 minus 81 is positive 19. Again, on number 4, I do not have a number in front of my x squared, so I'll just look at 20. Half of that is 10. 10 squared is 100. So x squared plus 20x plus 100 plus 94 minus 100. So that's x plus 10 quantity squared minus 6. And the last but not least problem is 5x squared plus 8x. And I don't have a term over here that I'm adding, so you can kind of think of that as plus 0 if you want to. I'm going to write this up here. 5x squared plus 8x. When I look at these first two terms, I want to take a 5 out because I need to get this term in front of x squared 1. So that's going to be 8 divided by 5x. So I'm going to take the middle term, 8/5, and I'm going to divide by 2. When I divide fractions, you always keep the first, change the division, to multiplication, and flip. That was 2 over 1, so it's going to become 1 over 2. So I took half, that's going to be 8 over 5 times 2 is 10. Square this number. So 8 squared is 64 over 10 squared is 100. So we're going to do 5 times x squared plus 8 over 5x plus 64 over 100 minus 5 times 64 over 100. Now let's reduce this. So that's going to be 5 times x plus, that is 8 over 10 when I take the square root of that squared, minus 5 goes into 100 20 times. So that's going to be 64 over 20. You can reduce these fractions. 8/10, of course, would reduce to 4/5, and 64 over 20 would be 16 over 5. It's not necessary at this point to reduce these, but absolutely you can. And you can multiply them back out to make sure that you get your original problem.